So we are going to talk or have talked about two types of nuclear reactions that generate large amounts of energy. Nuclear fission, that's the energy used in nuclear power plants. And this is the second one, nuclear fusion. So the word fusion means to join together. So when you fuse things, you bring them together, right? So nuclear fusion is when you have small nuclei and you join them together to form or make a larger nucleus. So it's going small, making bigger. Nuclear fission, which we went over in a different video, that's the splitting or breaking apart. So it's where you have a larger nucleus and it breaks apart into smaller nuclei. Now, this is very, very important because it is the type of nuclear reaction that is the energy for our sun. So nuclear fusion is an energy reaction occurring on the sun. You can see here, these are two isotopes of hydrogen. It's called deuterium and tritium. So these are two isotopes. Let's see, deuterium and tritium. I've got to kind of spell it out. So those are two stable isotopes of hydrogen, and they are in the sun are joined together to form helium, and then this is a neutron. Plus, just like in the fission, lots of energy. Now, this particular reaction would be a wonderful energy source for our power plants because it doesn't have radioactive isotopes as part of its products. So it forms helium. However, fusion, they cannot reproduce it in a lab. It has to have very high temperatures and pressures for it to occur. So the sun is a perfect place for this reaction to occur. However, in a laboratory, they can't replicate the conditions of the sun. So every once in a while, you'll hear in the news about researchers who think they have performed a cold fusion reaction. That's their attempt to try to get this reaction to occur at temperatures and pressures that are less than on the sun. So I think people have thought they've done it, but at this point, I don't think it's ever been replicated. So it has to be able to be replicated to be considered plausible. But maybe someday, I don't know, there's people who are skeptical that this will ever happen, but maybe someday in the future, this could be a way that we could use our energy that we need to produce electricity without some of the negative things that go along with nuclear fission reactions. So for nuclear fission, this is the reaction this is the reaction. And so what I want you to know is that this is the source of energy in the sun. Okay. I want you to know the definition of fusion. I want you to know that it takes extremely high temperatures and pressures, and so it's not duplicated in laboratory conditions. But other than that, that's what I want you to know about nuclear fusion. I hope I didn't confuse you. This is fusion. I kept saying fission, but this is fusion.